Hi everyone, this is Miss Lloyd coming to you with types of sequences. We're going to be looking at arithmetic and geometric. And then later on in this lesson, we're also going to focus a little bit more just on arithmetic sequences. So we're going to be going over two sections today. So an arithmetic sequence. So arithmetic, the sequence is said arithmetic, but whenever my mom was in high school, they called the class that she took arithmetic. So this is stuff that my mom did whenever she was in school, and this was the most math she did in school. So arithmetic just means that we're adding by the same number every time. So the difference between any two terms is some constant number. So the number we're adding every single time in order to get the next number in that sequence, in that list of numbers. So we're looking at the pattern. So here there's a little example of an arithmetic sequence. So we go from 9 to 7 to 5 to 3. So we can see here that we're subtracting by 2 every time to get from one number to the next. So that's an example, has a dot, dot, dot. And here in a moment, when we actually go to the example, it'll have a bit more instructions, but I just want to make sure you saw an actual example of an arithmetic sequence. So just a list of numbers, they have that similar pattern. So when it comes to geometric sequence, and feel free to pause the video anytime you need. If say I'm going too quickly, you can rewind, you can slow me down, you can speed me up, whatever it is you need. That's the best thing about these videos, huh? All right, so geometric is when we're multiplying every time to get from one number to the next. So in this case, instead of the difference, we're calling it the ratio. We can use division in order to figure out what we're multiplying by. So you can see that you're multiplying by the same number every single time. And that number we multiply by, we're going to call the common ratio. All right, so then here for our first example, they want us to find, they told us it's an arithmetic sequence, and they want us to find the common difference and state what the next two terms are. So here we already figured out the common difference. So D is going to be -2. We keep subtracting 2 every single time. So then my next two numbers, so 3 minus 2 will give me 1. And then 1 minus 2 will give me -1. So next two terms, that's all it's asking for. So -2 gave us that 1. And then minus another 2 gave us that -1. And we're done. So just looking at the pattern, figuring out how to continue. Next one. So looking at this, it looks like we're adding by 1.5 every time. So that means my common difference here is 1.5. So if I continue, I add 1.5 to 7.5, I'm going to end up with 9. And then when I add 1.5 to 9, I'm going to end up with 10.5. Ta-da! So geometric sequence, remember the pattern here, because we know it's geometric, we know we're multiplying or dividing. So for this one, it looks like we're dividing by 2 every time. And remember, dividing by 2 is the same as multiplying by a half. So whenever they ask you what your common ratio is, your R, you're looking at what you're multiplying by. So here we're going to say our R is a half. And so my next two terms, so now that we found the common ratio, we want the next two terms. So that means I'm doing 10 times a half, or divided by 2, which will give us 5. And then 5 times a half will end up with 2.5. Or you could say 5 over 2 if you wanted to. Either one is fine. You can do decimal or fraction. It doesn't matter at this point. Next one. In order to go from square root 6 to just a regular 6, I had to have multiplied by square root 6. Oops. And then here, in order to get from a 6 to a square root 6, or 6 square root 6, we would have to have multiplied by a square root 6. So I know this is my R, my common ratio, square root 6. So when I multiply my 6 square root 6 by a square root 6, I end up with 6 times 6. which will give me 36. And multiplying that by square root 6, I'll have 36 square root 6. So it seems a little complicated, but it's not that scary. All right, next bit. So given the formula, so they've given us a formula for the nth term. So nth term is just saying like any term, 11th term, 71st term, first term, 7th term, whatever. They're just giving us this formula to find each of those terms. So whenever they're talking about the nth term and they want us to find t sub 1, t sub 2, t sub 3, and t sub 4, they're talking about first term and second term and third term and fourth term. So we're going to be plugging in 1, figuring what that is, plugging in 2, figuring out what that is, 3 and 4, etc. And then they want us to look at the pattern, see if it's arithmetic, geometric, or if it's something else entirely. So then here I will be doing this in a nice rainbow order because I love rainbows. I love colors. I actually recently bought a rainbow purse. I'm really excited for it to come in. Ordered it off of Amazon because who's going to be going outside right now? Not me. All right, so we've got t sub 1, and so that means I'm plugging in 1 to my n. So instead of my n, I have a 1. And then minus 1. So then 1/2 times 1 will give me 1/2. And then 1/2 minus 1 will give me negative 1/2. And then I'm going to be plugging in 2. So 1/2 times 2 will give me 1. 1 minus 1 will end up giving me 0. And then we're plugging in 3. So 1/2 times 3 will give me 3 over 2. 3 over 2 minus 1 will give me a positive half. Move this a little bit. Might give myself quite the room I should have. And then plugging in 4, so finding the fourth term. So 1/2 times 4 will give me 2. And then 2 minus 1 will give me 1. So now we have to look at the pattern and see, okay, how would we get from 1/2 to 0, 0 to a half, half to 1? And so the pattern here is we would be adding by a half every time. So because we're adding by the same number every time, even though it's not a whole number, we're still adding by the same number every time. So this is going to be arithmetic. So here, again, I'm trying to find all of my t's. So actually, I'm going to cheat a little bit. It's writing for me, duplicate, move it over here. I know it's magic, isn't it? I love this app. If you want to know more about it, just leave a comment. I may tell you. Depends. All right, so here I'm plugging in 1 for n for my first term. So 1 squared is going to give me 1. 1 minus 1 will give me 0. Plugging in 2. 2 squared will give me 4. 4 minus 1 is going to give me 3. Plugging in 3. 3 squared is going to give me 9. 9 minus 1 is going to give me 8. And last one, plugging in 4. 4 squared is going to give me 16. 16 minus 1 is going to give me 15. So looking at this 0 to 3, we would have been adding 3. But if I add 3 to 3, it's not going to give me 8, it would give me 6. So that doesn't work. And there's nothing I can multiply by to get from 0 to 3, because anytime I multiply by 0, it's just going to automatically give me 0. So because I'm not adding by the same number every time, and I'm not multiplying by the same number every time, this is going to be neither. There you go. So it's not either one. It's neither, however you want to say it. It's not arithmetic nor geometric because we're not adding by the same number. That'd be plus 3 and then plus 5. And then what, plus 7. So you can kind of see a pattern in how we're adding, but we're not adding by the same number every time, so it's not going to be arithmetic. And there's nothing we can multiply for all of these in order for them to continue. So it's not geometric either, just neither. It's actually a song about that. All right, so next one, I'm going to be doing the same thing. So I'm going to, duplicate this, move it over here. So I'm plugging in 1 for the first, so I'll have 1 minus 1, so that'd be 2 to the 0 power. So 2 to the 0 power is just 1. So we've got 1 over 4 for that situation. Next one, we're plugging in 2. So 2 minus 1 would give me 2 to the first power. So 2 to the first power over 4 would give me a half when I simplify. The next one, I'm plugging in 3. So 2 to the 3 minus 1. 3 minus 1 would give me 2. So then 2 squared would give me 4. So 4 over 4 is going to simplify to 1. And then last one, 2 to the 4 minus 1. 4 minus 1 is going to give me 3. So 2 to the third power is going to give me 8. 8 divided by 4 is going to give me 2. So here going through, there's nothing, I could add a fourth to 1/4 to get a half, but adding a fourth to a half isn't going to give me 1. But looking at the other number, so if I multiply by 2, so times 2, and works there. Half times 2 would give me 1, and 1 times 2 would give me 2. So because we're multiplying by the same number every time, this is going to be geometric. Ta-da! I feel so smart, but I also feel crazy for talking to myself. Although I know I'm talking to you, but I feel like I'm talking to myself. It's also an empty classroom. I'm not a big fan of this. All right, so next bit, we're finding the next term in the sequence. So it starts with 1, and then goes to 4, and then goes to 8, and then goes to 13 and 19. So we want to figure out the pattern, how it's going from one term to the next, and we want to continue that pattern. So looking at this, I always like to check out the addition first. So it would have been adding by 3 to get 1 to 4. Adding by 4 to get 4 to 8. 8 to 13, we would add 5. 13 to 19, we would add 6. I feel like this is a nice pattern. I don't have a specific name for this pattern right now. It's not arithmetic because it's adding different numbers. But I can see the pattern going on. So we added 3, added 4, added 5, added 6. So I know from here, I would add 7 to 19. And so 19 plus a 7 would give me 26. So we figured out the differences, or figured out how to go from one term to the next, and then we found the next term. So then we're done. Ta-da! All right, and then now we're gonna go on to the next section. So sometimes even if something is not arithmetic or geometric, we can still see a pattern and continue that pattern. So it doesn't have to be arithmetic or geometric in order for us to continue our good work of mathematics. So this next section, we're going to focus solely on the arithmetic sequence. And so with our arithmetic sequence, we actually have a formula for this. So our formula for the arithmetic sequence is T sub n. So remember, that's kind of specifying which term you're looking at, depending on what n is. And so in order to make this formula, we'll look at the first term, add that to our term number minus 1, and multiply that with the difference, so what we're adding and subtracting by each time. So then here, just a reminder, T sub 1 is our first term. And then D is our common difference. So what we're adding or subtracting by every time. And then N is talking about the specific term number that we're looking at. If we do something like T sub N, so say it's T sub 7, then we're looking at the 7th term. And so we're plugging in 7 to the formula itself. So T sub 7 would be saying the 7th term is equal to, and then you could solve out, say the 7th term is 84, whatever it ends up being. All right, arithmetic means. So what it's talking about is the term in between other terms. So say I have an A here, we don't know what this is, and then we have B. So arithmetic means is the term in between the terms. So whatever this ends up being. Although it could be more than just one. It doesn't have to be that one solitary one. And so by doing that, we can think of what we would have plus D plus D. So A plus D would be equal to B. We would have gotten to B, so we would have had to add our common difference twice in order to get from A to B. And so I want you to keep that in mind whenever we start looking at this. There is a quote unquote formula for it, but I almost never use a formula because I like to use my common sense and my knowledge of what an arithmetic sequence is instead. All right, so here they want us to find the nth term of the following arithmetic sequence. So when they talk about the nth term, they want the formula. They want that thing. So we're going to leave it as t sub n. We just need all the rest around it. They're not going to give us n, so we need to find the first term and the common difference, d, and we'll plug that in, simplify what we can, and just leave it as t sub n. We're going to leave the n where it is. Hello, Mr. Costas. I'm doing a recording of a video. Bye, Mr. Costas.
I'm going to see that video. Hello, guys, and listen carefully to the video.
That was Mr. Costas telling you to listen. Arithmetic sequences.
That's my favorite topic.
Okay, thank you, Mr. Costas. Oh, one thing about staying here and doing work in the classroom. Anyone can walk in. All right, so we've got our first term that we're going to need, so our t sub 1, we know is 7. Again, we don't need n, but we do want to figure out what the common difference is. I'm going to move this down a little bit. So in order to get from 7 to 11, they did tell us that it's arithmetic, so I know I'm adding every single time. So in order to get from 7 to 11, I would be adding 4. Same with 11 to 15, we're adding 4, adding 4. So then my common difference would be 4. So I'm looking at t sub n. Again, we're leaving the n. And then I'm plugging in my 7. Plus, again, leaving our n. And then multiply by 4. So here I can do some distribution and try to simplify some terms. I'm going to distribute in my 4. So I've got 7 plus 4n minus 4. Combining my 7 and my minus 4, t sub n is going to be equal to 4n plus 3. And then we're finished with that. So I'm leaving my n's in and solving for the rest, or simplifying what I can. All right, so our next example, they want us to find the arithmetic mean between the following. So that means we have negative 7.8. We're trying to find the number that's in between that and 3.6. So we know that they're adding by the same number to get there. Also, we could think of mean as being average. So we're basically trying to find the average between these two, which means we can add, so negative 7.8 plus 3.6 and divide by 2. This ends up getting us negative 2.1. Doing the same thing for this next one. So we're looking at 1/2, trying to find the number in between that and 1/3. So we're adding 1/2 plus 1/3, dividing by 2. And if fractions freak you out, you could plug it into your calculator. That always works. Or you could change this to 3/6 plus 2/6. So then that's 5/6. And whenever we divide by 2, that's the same as multiplying by 1/2. So same change, flip. And we've got 5/12. Our next, they want us to insert 3 arithmetic means between 18 and 54. So we have 3 numbers in between. This you can do the same, adding these two together, dividing by 2 to get our middle. You can add those two together, divide by 2 to get that one, so on and so forth. But it's not always going to be that nice where you have a clean middle. So instead, I'm going to show you how to do it a little bit differently. So knowing it's arithmetic, that means I'm adding by the same number every single time in order to get from one to the next. So that means in order to get from 18 to 54, I added D, 4 times? So in order to get that 54, so I can do some subtraction, some subtraction. 1, 2, 3, 4. Yeah, I did that right. All right, and then 18 minus our 54. So we're going to have 4D is equal to, when I subtract 18 and 54, well, we end up with 36. And then so D is going to be equal to 9. So that means I'm adding 9 every single time to get from one to the next. So I'll add 9 here. It'll be easier if I do it this way. Add 9 here, I'll end up with 27. Add 9 again, I get that 36 that I would have gotten in the middle. And then add 9 again, I would end up with 45. Adding 9 one more time, I should get the 54. So that's a way to check yourself that you did it correctly. And then we're done with that. So then last two, they want us to find the specific term for each arithmetic sequence. So this one, they're wanting the 17th term. So we're using that same formula that we saw at the very beginning. Oops. So t sub 17, we need the first term, in this case is 2. That's our first term, so 2. And then plus, we're using 17 for our n since we're trying to find the 17th term. And then our common difference, put this down a bit, we're trying to figure out what we're adding every time. So in order to get from 2 to 5, we'd be adding 3. Same with 3 to 8. Or sorry, 5 to 8, we're adding 3. And so we're multiplying this stuff together. So t sub 17, or t sub 17, we're doing 17 minus 1 is just 16. And then 16 times our 3, we would end up with 48. And then 48 plus the 2 will give us 50. 17th term, done. Not too crazy, right? And then our very last one. This, because we're given, the second term and the 5th term, I want to do like I've done before, so like we did in the previous example. So I'm a very visual person. I like to see this happening. So I don't know the first term, but I know the second term is 9. I don't know the third or the 4th term, but I know the 5th term is 21. And so we're trying to find the 41st term. So in order to do that t sub 41 stuff, I need the first term and the common difference. So to find the common difference, I know I did added by d 3 times in order to get to the 21. So 3d would have given me that difference of 21 minus 9 would give me 12. So my d, my common difference, would be 4. So I'm adding 4 every time. If I'm adding 4 every single time, then in order to go from the first term, adding 4 to get 9, my first term had to have been 5. So 5 plus a 4 would have given us that 9. And so now that I have that bit, I can do t sub 41. Let's use that color for 41. Is equal to, I know my first term now is 5. Plus, again, we're finding the 41st term, so 41 minus our 1, and we're multiplying by the common difference, which we found was 4. So then 41 minus 1 is going to give us 40. 40 times 4 would give us 160. So then 5 plus that 160 will be 165. And we are finished. All right, so if you are one of my students, I have posted our homework on the LMS, so what all you have to do, so go ahead and look at that. I have amended how I would like you guys to turn in the homework. So I would like for you to use the Dropbox on the LMS page and only email the questions you have on the homework instead of emailing me your homework assignment. That way it's easier for me to tell who needs help and who's just turning something in. So we'll turn in through LMS and email me with the questions that you have. And if you're not one of my students, feel free to leave a question in the comments if you have one, and I'll do my best to answer for you. So, Matthew regards, Miss Lloyd.